Hey gang, so we are on page 7 of our packet. Alright, so we are to the part about tangent lines and the rate of change. So we've been finding limits of functions and we've been plugging those in, and we learned about the polynomials and how to find the limit of a polynomial. You can just plug in the value of the limit of what you're approaching. Let's take a look at what's next. Using limits to find the slope of the tangent line. Okay. This is going to be an intense algebra heavy lesson. So if you're not ready to watch it, like if you're like, oh, I'm just not feeling it, don't watch it, because you need to be coffeed up and caffeined up and ready to go for this lesson. It is going to be algebra on steroids. All right, here we go. If I'm finding the slope of a line, and I did just get my nails done, aren't they super fun? What? Okay, a slope of a line. Here's the slope of a line. y2 minus y1 over x2 minus x1. I'm going to use that formula over and over and over and over today. Here we go. This is what we're going to do. We're going to find the slope of the tangent line. You already know what the tangent line. We have done plenty with the tangent lines. Okay, so here's my curve. And I'm going to put my point P on it. We've always been using P and Q. So here's my point P. I'm going to say that P has an ordered pair. I'm going to call this X, and this right here, remember thinking algebraically, if this is X, this would be f of X. Now, I'm going to have 2 points on here, so what I want to do is label this X naught and Y naught, or X sub 0 and Y sub 0. It doesn't matter to me what we want to do it there. Then I'm going to put another line, a point on my line, and I'm going to label this Q. The ordered pair for Q. Q is going to be the point where we move over just a little bit to the other side of P. Now, I'm showing it as a big amount so that we can kind of see it with our eyes. But imagine if P and Q were super, 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 super close. They're really, really, really close. Okay? So this one right here, I'm going to call this the same thing, but I'm going to add just a little bitty bit to it. I'm going to say plus just a little bitty bit, and that little bitty bit is going to be H. Now, that would mean if this is X plus H, so whatever this value is, what would this value up here be? You would go over X plus a little bit, and to find up here, you would take F of that little bitty bit, and that would give you this. Just like this is over X, this is f of X. F of X and Y are the same thing. This would be X naught plus H. And this would be f of X naught plus H. So here we go. Let's label the ordered pair. This one is X naught plus H. And this is f of X naught plus H. That's the ordered pair there. This ordered pair is X naught and then f of X naught. Some of you are probably already realizing what we are about to do. Okay, if I want to know the slope of this line, right here, this line that goes through, and I'm going to get my pencil, my little piece of paper that I had, my little eraser I was using the other day. I'm going to connect this. There's my line. I want to know the slope of that line. Now, I know right here it looks like, okay, that's not a tangent line at all. But remember, we can move Q really, really close so that it is a tangent line. For now, I'm just going to say, you know what, guys, that's a secant line. It's just 2 points on a curve connected with a line. That's a secant line. This right here, it's some point, some random point. I have no idea what random point it is. This is some point plus a little bit. Not much, just a little bit. So some point plus a little bit. Not much at all. Just a smidgen. If I knew how to spell smidgen, I might actually call it a smidgen. Okay, so here's what I want to do. I want to find the slope of PQ. Rise over run, delta y over delta x, or y2 minus y1. y2 minus y1 over x2 minus x1. I'm going to give you a second, and I'm going to have you write it down. Here we go. y2, f of x naught plus h, minus y1, which is f of x naught, over x2, which is x naught plus h, minus x1, which is x naught. Okay, simplify. There's one simple step we can do here. On the top, I can't really do anything. That's f of x plus h. Oh, I put the naught in the wrong spot, y'all. That's funny. Minus f of x naught. But down here on the bottom, do you see where x naught and x naught cancel out and I just have h? That means that the slope of the secant line is this. And now remember, the slope of the secant is the same as the slope of the tangent line. That's the slope of the tangent line. What? Okay, if I let Q move really, really close to P so that, let's start this. Let's let point Q get really close. You know those limits are coming. Really close to P. So that what's going to happen? We're going to say that H right here, H is going to get really, really close to X. We're just basically moving H really close. We're moving Q down, which means that H is moving really close. So we're going to say that H is approaching. If the distance between these two values right here is getting smaller, 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 H would be, in essence, approaching 0. If this distance were 10, and then we shorten it and we say this distance is 9, then it's 8, then it's 7, then it's 6, then it's 5, then it's 4, then it's 3, then it's 2, then it's 1, and then it's just 1 and a little bit. It's just halfway. It's 3/4 of the way. It's approaching 0. Meaning we have a limit as H approaches 0. All right, that's what we're going to work with. We're going to work with that limit that we are finding the slope of that tangent line, and what we're doing is we're moving Q closer and closer, and what we're doing is we're reducing this distance here, and we're going to get as close as we possibly can to X without actually reaching it. So let's do an example of how this is going to work. And you may remember this on what day? On Thursday, we did this one in class. We did find the equation of the tangent line. If you look at your notes, the very first page, we already did this. But let's do it differently. Here's what we know. We know that f of x equals x squared. We know that we are going to find the tangent at the point 1, 1. So that means that this would be our starting amount, and this would be f of x. So if you think about it like this, if you were to graph it, this point right here, P, well, that would be 1, 1, or just like we had labeled up there, x naught and f of x naught. And then we're going to have another point up here, Q, and Q is going to be x naught plus just a little bit. Well, if x naught is 1, wouldn't I replace that and say this is 1 plus h? And then this point up here, which is f of x naught plus h, just going off that one we did a while ago, it would be f of 1 plus h. So let me label my ordered pair. This is over 1 up 1. This is over 1 plus h. And then f of x naught plus 1 h, but we know it's 1 plus h. 1 plus h. Bam. There's my two ordered pairs. Okay. We learned earlier that the slope of the secant line was f of x plus h. I'm going to say the naught, and sometimes I'll probably forget to say it, but you know it's there. all over h. Could we drop it? Yeah, theoretically we could. I'm just doing it so that the notation looks better. This is what we found the slope of the secant line to be, which we know from earlier the slope of the secant and the slope of the tangent are the same. So using this, I want to find the slope of the tangent line. The slope of the tangent line, because that's what it wanted me to find. If I'm going to write the equation, I have to have a point, I have to have a slope. I have a point, but I don't have a slope. I'm going to say it's this. It's the limit as h approaches 0 of this. F of. Now, I know x plus h is this one right here, so I'm going to use these two ordered pairs. So it's going to be f of, I'm going to use this, I'm going to put it in here first like this so that we can see it, minus f of x all over h. But here's what I know. I know the function. So when I do f of x plus h, I'm going to be able to plug that in. So I'm going to say the slope of the tangent line is the limit. I guess I could have just put this and not the other part. Here we go. I need to find f of 1 plus h. So here's, because I'm going to plug that in right there, and then I'm going to do f of x. You already know f of x, right? You know f of x is 1 right here. But I don't know f of 1 plus h. What that says right there, and I'm going to come over here to do this over here just a little bit. I need to find f of 1 plus h. Hopefully from your Algebra 2, you remember this. I'm starting with f of x equals x squared. Everywhere I see an x, I plug in whatever value I give. I'm giving you the value 1 plus h. That means I need to take that squared right there and plug in 1 plus h. Everywhere there's an x, I'm going to plug this in. Let's do that. What is f of 1 plus h? Okay, that's 1 plus h times 1 plus h. I'm going to do a little bit of math here. 1 times 1 is 1. 1 times h is h. H times 1 is h. H times h is h squared. That is 1 plus h is 2h plus h squared. So f of 1 plus h is that right there. All right, I'm going to come over here and I'm going to go ahead. I'm going to plug in this just so you can see what we're doing. F of 1 plus h minus f of 1, or f of, can't say it, f of x naught is really f of 1 because we're plugging in 1. All over h, which in this case we're going to leave as h. So the limit as h approaches 0. F of 1 plus h, I know it's that right there. So it's 1 plus 2h plus h squared. It's all of this minus f of 1 is 1 all over h. Let's simplify. Every time, y'all, every time you have to write limit. You have to finish that out. Okay, are you good if I do this? One positive 1 and a negative 1 are going to cancel out so that I have 2h plus h squared over h. If I have an h and an h on top, I can factor that out. So I'm going to do this. I'm going to say the limit as h approaches 0. Remember I said it's a whole lot of algebra today, y'all. I'm going to factor out an h, which will leave me with 2 plus h all over h. I'm going to let you look at what I just did. I factored a 2 out. If I were to redistribute, I would get 2h plus h squared. 2h plus h squared. Oh, look at that. H and h cancel out. So the limit as h approaches 0 of 2 plus h. From here, that's a polynomial. I am just going to plug that 0 right in there, and I'm going to say equals 2 plus 0, which is 2. Bam! That, my friends, is the slope of the tangent. I just didn't keep writing that, but that means the slope of the tangent line is 2. So I'm going to get a different color so it kind of sticks out a little bit. I'm going to do it in green. Here's what I know. The slope of the tangent is 2 going through the point 1, 1. So y minus 1 equals 2 times x minus 1. Y equals 2x, and that would be minus 1. And that's what I was looking for. The slope of the tangent line that goes through 1, 1. Now, was that a little bit harder than what we did before? Maybe. But boy, the math you just did right there and the calculus, my friends, oh, I love it. I love it, I love it, I love it. Okay, let's try another one. Find the equation of the tangent line to y equals 3 over x at this point. Same thing we are going to do. Here's what I know. If I'm finding the tangent line and I'm going to write the line, I need to have a point and I need to have the slope. Well, I have a point, don't I? The point is 3, 1. But what is the slope of the tangent line? I don't know. I have to figure it out. All right? I do know this. I do know that the slope of the tangent line is the limit as h approaches 0 of f of x plus h minus f of x over h. I know that. That's the rule that I know. Can I figure out everything to plug it in? All right, well, let's see. What is f of x? F of x is 3 over x, okay? I know f of 3, right? F of 3 is what? F of 3 is 1. All right, so I'm going to let you think about that for a second. I know f of x, f of 3 is 1. So be thinking about what's going to go here. Okay, so now I need to know what is f of x plus h. I guess I should put my knots in there. F of x plus h. So that would be f of, what is x naught? That's right there, that's 3. So 3 plus h. And if you think about where you are on the graph, I wonder if I do have a little bit of room. Because sometimes when you're labeling these, it gets a little bit tricky. I'm going to go over 3 and up 1. And that's this first point right here. That's 3, 1. So think about, I'm just going to draw a curve. I know it's not the right one. Here's my next point, Q. If this is 3, remember we're going to go out here. We're going to go x naught plus h. How much did I go over? I went over 3 plus a little bit. 3 plus a little bit. Let's figure out what f of 3 plus h is. Well, that would be, here's what f of x is. So we're going to have 3 over, and then now I need to plug that in, and that's going to be 3 plus h. So f of, let's say 3 plus h equals this. So I've got this right here. I've got this one, and I've got this one. You with me? Hopefully you're with me still. So here we go. We're going to find the slope of the tangent. We're going to do the limit as h approaches 0. And we're going to use our formula here. F of x plus h. Well, f of x plus h is this right here. Okay. I wonder if it would have helped to write out our ordered pair. We have 3, 1, and then we have 3 plus h, 3 over 3 plus h. I wonder if that would help you see that. X, f of x, f of x. This is x plus h, f of x plus h. Okay. Where am I at? So we're going to plug this in. So x plus h would be this one. So that'll be 3 over 3 plus h minus f of x, which was this one right here. Oh, sorry, 1. I put 3. F of Move that there. F of x is the 1 over h. Once you get to there, it's just a matter of solving it. So here we go. The limit as h approaches 0. Whew, how am I going to solve this? Well, in order to put these together, I have to have a common denominator. So if you remember, I can put 3 plus h, this is 1, so I can put 3 plus h over 3 plus h. So I'm going to do 3 minus parentheses 3 plus h over 3 plus h. Now, let me just kind of on a side note show you what I did here, because that was a lot of math right there. 3 over 3 plus h minus I'm going to put a bar there. I have a 1 right here. I need to change this 1 so that it has a common denominator of 3 plus h. If I put 3 plus h on the bottom, I have to also put it on the top. 3 plus h divided by 3 plus h is 1, which is what I have here. But I'm going to be subtracting, so I need to remember that this whole thing right here is being subtracted. So I've got 3 minus 3 plus h, all over 3 plus h. Ooh, there's some major thunder going on tonight, guys. So that is 3 minus 3 minus h. 3 minus 3 minus h, all over 3 plus h divided by h. Now, I'm kind of not doing this here. I'm kind of just working this over here on the side. When you're working with limits, you have to always write limit every single time. But sometimes when you get into the algebra, I like to come to the side, kind of simplify my algebra, and then come back over here. Just make sure, like I kind of shouldn't have done that right there. I shouldn't really put an equal sign right there, because these are different problems. Like this is simplifying, this is doing a limit. And so I want to be real careful with that. 3 minus 3 is going to give me negative h over 3 plus h. Here's what I'm going to do here. I've got this division bar. I'm going to say all of that is divided by h. Do you remember? I'm like so much algebra here, y'all. When you divide by a variable, you want to change it to multiplication. So this would be negative h over 3 plus h. Multiply, put that over 1, flip it, and make it 1 over h, and then multiply. This h and this h will cancel out. Negative 1 times 1 will be negative 1 over 3 plus h. So all that mess simplifies to that. That means I can come back over here and I can say the limit as h approaches 0 of negative 1 over 3 plus h. Because all of that simplified to that. Oh my gosh. All I got to do is plug it in now. So I can say the slope of the tangent line is negative 1 over 3 plus 0. I'm going to actually plug in that value. That's negative 1 over 3. I'm going to check my answer key, make sure I got that right. Yeah, I did. So the slope of the tangent is negative 1/3. So I'm going to go back up here in green, and the slope of the tangent line is negative 1/3. Can I write the equation of a line? You bet. 3, 1 with a slope of negative 1/3. Y minus 1 equals negative 1/3 times x minus 3. Y minus 1 equals negative 1/3 x plus 1. Y equals negative 1/3 x plus 2. Yep, that's what I got on my paper too. All right, that's a whole lot of math going on there. Whole lot of math going on. All right, so here we go. We are on to number 11. I had a little typo on this one that I already corrected. All right, so find the slope of the tangent line to y equals the square root of x at any point. Okay, so let me just go back. This one, that is really close. Let's try that again. We found this one at the point 1, 1. And then we did this one, and we found the slope of the tangent at the point 3, 1. But what if I didn't want to know a specific point? What if I want to know, in general, is there a way that I could do the slope of the tangent line to any point? What if they didn't give me a particular point? And what if I had to do the work to find, like, any point? And they give me 5 points, and I have to find the slope of each of them. There is a way. It is not that difficult, and it is mind-blowing how you can do this. All right. So first, I want to highlight on this the word any. And then you can draw a little mind-blown picture if you know how, but I'm just going to write the words. Every point is different. Every point is different, meaning I can pick 3, 1. I can pick 1, 1. I can pick any point I want on this line. All right, so here we go. I know this. I know that the slope of the tangent is the limit as h approaches 0 of f of, and I'm going to switch and just put h plus 0. I'm going to leave off the h naught minus f of x all over h. It's still representing any single x that I want. I'm just going to remove the x naught for now. All right, guys, here's what we know. We know that f of x equals the square root of x. That means if I plug in x, the output is the square root of x. You with me there? That sounds pretty good. Now I need to find f of x plus h. That would be everywhere there's an x, I'm going to put x plus h. The square root of x plus h. I'm replacing the x with x plus h. So my ordered pair would be plug in x plus h. The output is the square root of x plus h. I wanted to write it like this. I think I should have done that on the video on the other ones like that too. So when I teach this in class, I'll probably do it that way, but I didn't think about it until right now. All right, so let's just do the limit. Here we go. The slope of the tangent line is the limit as h approaches 0 of. Now, do you know enough now we can just plug this in, right? F of x plus h. That would be this one right here, right? So that will be the square root of x plus h minus f of x. So minus f of x would be the square root of x all over h. Oh boy. Now, I don't know if you remember how to solve this or not. I'm going to kind of help you. You had to use something called a conjugate. I don't know if you remember what that is, but that is where you multiply by the number 1. 1 times anything, you don't change the equation. But on this one, the number 1 that we're going to choose is the conjugate. It is where we're going to say x plus h plus the square root of x over the square root of x plus h plus the square root of x. Because this divided by this is the number 1, we haven't changed anything. But when we multiply this, because now this is the difference of perfect square, well, not perfect squares, but we're about to perfect square it, this squared, the middle terms are going to cancel out. And you're going to have this times this minus this times this. And it's going to really help us as we solve it. Okay, so here we go. The limit, yeah, you got to write it again. As h approaches 0. Ooh, I don't think y'all can hear that, but oh my goodness. All right, we're going to multiply these together. When you multiply radicals, you just get rid of the radical. So that'll be x plus h, and that'll get those two, minus, because negative times a positive is a negative. And then we're going to do this one right here, and that will give us x. Now, I hope I didn't do the algebra here, but I hope you realize that you are actually doing double distributing. This times this times this. These two together, and then these two together. But because one's positive and one's negative, the middle term is going to cancel out, and you end up doing this times this, and this times this, which is what happens here. Now, right here on the bottom, because you're trying to factor, you're going to be real careful here. And we're going to say h times, and we're going to put the square root of x plus h plus the square root of x. And we're not going to hippity-hoppity distributed property here. We're going to keep it like it is. Because, watch what happens. X plus h minus x. Oh, those are gone. When I write the next line, the limit as h approaches 0 of h over h times the square root of x plus h plus the square root of x. What happens to those h's? They cancel out. That's why you don't want to distribute that. So I'm left with a 1 up here. So here's what I've got. I've got the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. When you try and simplify the slope of the tangent line right here, when they get all messy, you're always trying to get rid of the h's. You want to get rid of as many h's as you can. So here's what we've got. The slope of the tangent line equals, we're approaching 0, 1 over the square root of x plus 0 plus the square root of x. All I did was plug in that 0. Here we go. 1 over the square root of x plus 0. Isn't that just the square root of x? The square root of x plus the square root of x. Do you remember how to add those? They work just like variables. So there's 2 of them, and you keep the name there, which is the square root of x. Oh my gosh! The slope of any tangent line on this curve is 1 over 2 square roots of x. What? That is for any point. So I'm going to put a box around that, and I'm going to say mind blown for any point. That is how you find the slope of the tangent line. Okay, so let's see. I had used info to write equation at 1, 1. So let's say I give you this scenario and I want to write the equation at 1, 1. So let's say write the tangent line at 1, 1. Okay, I say 1, 1 because if I plugged in 1 right here, what's the square root of 1? It'd be the point 1, 1. Hopefully that I didn't overstep anything there. You guys followed that. If I were to go back to the original equation and I want to know if x is 1, what is y? Well, the square root of 1 would be 1. So write the point 1, 1. 1, 1 is on this graph. Well, here's what we've got. The point is 1, 1. The slope is 1 over 2 square roots of x. Well, let's plug it in. 1 over 2 square roots, x is 1. So we're going to plug in 1. So that means it would be 1 over 2. Point, slope. All right, here we go. Y minus 1 equals 1/2 times x minus 1. Y equals 1/2 x. That'd be minus 1/2. I would add 1 to both sides plus 1. So y equals 1/2 x. 1 minus 1/2 would be a positive 1/2. Mind blown. And there it is. So, can you do it for any point? Absolutely. We can find it at any point. All right, so I am going to stop right there and continue on with another video on average velocity and instantaneous velocity.